Alright guys, what we're going to be doing today is 4.2c, solving systems of equations using mixed strategies. So far we've learned 3 ways to solve for systems. As a quick reminder, systems are just 2 lines, and we're trying to figure out where these lines intersect. That is the solution of a system. So the 3 ways we learned first was by graphing, then we learned substitution, and now elimination. Based off the problem, I'm going to show you can use either method, and then the final thing is you're going to have to decide which one to choose. So hopefully this video can help you out with that. So let's start with this one. We're going to start with this problem. It's a little different. It's actually one very similar to your test. Now it says, given the equation 3x plus y equals 1, write a second equation so that the system has a solution of 1 comma negative 2. So what it wants you to do is find, if I were to graph this line, so here's my first line, 3x plus y equals 1. It wants you to have another line where it intersects. So here's the first line. The second one, when you graph it, it's going to intersect at 1 comma negative 2. Okay? So essentially, I need to come up with an equation in y equals mx plus b form that has that point. So very similar, well, I'm going to write it in y-intercept form, slope-intercept form. That's y equals mx plus b. You already know that this is your x and this is your y. Now all you're going to do is make up an m value for 1. So if you look at your m value, just make up any slope that you would like for it. So I'm going to choose 2. So if I plug in these values, my y value is negative 2 is equal to positive 2 times 1 plus b. This simplifies to negative 2 is equal to 2 plus b. And when I minus 2 on both sides, you're going to get negative 4 is equal to b. So if I put my y equals mx plus b form, my slope of the line would be y equals 2x minus 4. And I want you to double check that that is the correct answer by going to Desmos. So if we just bring up Desmos really quickly, you can go ahead and do this on your graph. I want you to come up with your own. So I just showed you an example. You're going to come up with your own example. So while this loads, my equation was y equals 2x minus 4. And the other one that it gave me was 3x plus y equals 1. So let's add a new one right here. 3x plus y equals 1. And if you see where they intersect right here, that is 1 comma negative 2. So go ahead now, find a new example by changing this one, y equals 2x minus 4, and decide what that new equation is. Okay? So now let's go ahead and look at this one. Let's solve the system of equation by graphing, substitution, and elimination. So on this one, what I would like to do is get them both into slope-intercept form. So the first one, I would minus 9x, and this would give me negative 6y is equal to negative 9x minus 12. From here, I would divide each and every term by 6, which would give me y is equal to positive 3 over 2x plus 2. So here what I do is I go to plus 2, and then I go up 2 over 1, 2, 3, because that's my slope. Oops, actually I did it backwards. It's rise over run, so I'm going to go up 3 over 2. So up 1, 2, 3 over 2. Up 1, 2, 3 over 2. And then from there you can go ahead and graph your line, and it should look something like this. Alright, now the next one, x plus 2y equals 0. I'm going to same idea, get x by itself, or y by itself. So that'd be 2y equals negative x. Divide both sides by 2 to get y equals negative 1/2 x. So there is no b value, so I'm going to start at the origin of 0, 0. And I'm going to go down 1 over 2. Down 1 over 2. And now I'm going to see where these lines intersect. Alright, now it looks like that's not correct. Let me go ahead and draw a little bit more exact. Now it looks like by graphing this is where they intersect, and if I did everything correctly, which let me double check that I did that. 9 would be 3 over 2. 1, 2, 3 over 2, down 1, 2, 3 over 2. Okay, it looks like I graphed everything correctly, and I can't really tell exactly what that number is. So this is why we use substitution and elimination and whatnot. So let's go ahead now and solve for this. Now I want to solve by substitution, and in my opinion the easiest thing to do is get this x by itself. So I would minus 2y on both sides. So that would give me x is equal to negative 2y. So I'm going to substitute that into here. So I'm going to have 9 times negative 2y minus 6y equals negative 12. That gives me negative 18 minus 6y is equal to negative 12. And when I combine these y's, that's going to be negative 24y is equal to negative 12. When I divide both sides by negative 24, I'm going to get y is equal to positive 1/2. Okay, so now that I know what y equals, I'm going to go ahead and solve what x equals. So out of these two, it looks a little easier to plug in y equals 1/2 right here. So in blue, that's going to look like x plus 2 times 1/2 equals 0, which is x plus 1 equals 0. And if I minus 1 on both sides, it's going to be x equals negative 1. So, and by looking at my graph, you can kind of tell, okay, it's down 1 and up 1/2. And that's exactly what I got. So as an ordered pair, it would be negative 1 comma 1/2. Perfect. Okay, now we're going to solve the same problem by elimination. By looking at these, I think it'd be easiest to eliminate these y's, so I would just multiply both sides by 3. And I'm going to rewrite 9x minus 6y equals negative 12. And here now I'm going to have 3x plus 6y equals 0. When I add these up, I'm going to get 12x, these eliminate because negative 6y plus 6 is just 0, equals negative 12. And then so when I divide both sides by 12, I'm going to get x equals negative 1. Now that I know that x equals negative 1, I'm going to solve it the same way as I did previously. I'm going to plug it back into this equation right here. And that is going to give me negative 1 plus 2y is equal to 0. I'm going to add 1 on both sides to get 2y is equal to 1. I'm going to divide both sides by 2 to get y equals 1/2. So my ordered pair now is negative 1 comma 1/2. And that is my final answer. So I just solved it all 3 methods and I got the same answer all 3 methods. So the point of that is to show you it does not matter which method you use, you're always going to get the same answer. So go ahead and take a second now and write which method do you prefer. Do you prefer to solve by graphing, elimination, or substitution? And so go ahead and pause the video right here and write answer number 3 together. So for me personally, I like all of them. It really just depends on the problem, and once you become comfortable with it, you can choose which one you'd like to use for which situation. So what we want to do is examine the given systems and state whether we're going to use elimination, substitution, or graphing would be the best method to use to solve. I want you to explain your reasoning and the structure of the equation. Solve the system which method you chose. Shows all your work. Okay. So on number 4, what I personally think works out well is I would use substitution here. The reason I personally would use substitution is because we already have an x. X equals 4y plus 1. So if I were to set this up, it's already more efficient to set up x equals 4y plus 1. So if I write x equals 4y plus 1, then over here I have 2x minus 3y equals 12. all I need to do is substitute that in for right there. So that would give me 2 times the quantity of 4y plus 1 minus 3y equals 12. So when I distribute, this would give me 8y plus 2 minus 3y equals 12. And then I would minus 2 and combine like terms. This would give me 5y is equal to 10. And I would divide each side by 5 to get y equals 2. Alright, I might need to sneeze. Hold on. Nope, false alarm. Okay. So now that I know what y equals, I just substitute that in back here to get x is equal to 4 times 2 plus 1. That's x equals 8 plus 1 to get x equals 9. So your ordered pair here is 9, 2. That is where they would intersect if you put this into Desmos. And guys, I just want you to realize that you can check every single one of these answers using Desmos, so feel free to jump in there and do that. Alright, so now we have this next one. I have x plus y equals 3 and 3x minus 4y equals 19. You have 2 ways to solve this. You can choose to isolate one of these variables, x or y, or you can manipulate one of the equations so that you can eliminate one of the variables. To me personally, when I see this, I would multiply it by 4. If you see this and you're like, I prefer substitution, then you can use substitution. Remember, it's choosing your own method right now. So this would give me 4x plus 4y is equal to 12. So now when I add these, I will get 7x. These would be eliminated, and that will be equal to negative 7. When I divide both sides by 7, we're going to get x equals negative 1. So now that I know that x equals negative 1, I choose one of these 2 problems. The top one looks a lot easier for me to solve. So I'm going to get the equation now, negative 1 plus y is equal to 3. And we're going to add 1 to both sides to get y equals 4. So then your ordered pair is negative 1, 4. Alright. Next one, by looking at this one, I notice that I have x equals y equals x minus 6 and y equals x plus 2. When you have the 2 equations that are set, the variables equal, then all you have to do is set the 2 equations equal to each other. So when I have this, I have y equals x minus 6, y equals x plus 2. So I already know what y equals, so I'm just going to substitute that in there. So what that would look like now is x minus 6 is equal to x plus 2. You set them equal to each other when you have the variable all by themselves. And I'm going to start by minusing x's on both sides to get negative 6 is equal to positive 2. Hopefully you guys realize that this is not a true statement, therefore this is no solution. When we become more familiar with these problems, I want you to notice that they both have the same slope, but different y-intercept. Therefore, that would be a no solution. Alright, next one, let's go ahead and look at this problem now. Let's see. For me personally, I would use substitution. So let me go ahead and show you why. I already have y is equal to negative 2x plus 5. I already have y by itself. So then over here I have y minus 2x equals 1. I'm going to substitute this in here. So that will give me negative 2x plus 5 minus, just a regular 5, minus 2x equals 1. From there now I can combine like terms to get negative 4x plus 5 is equal to 1. I'm going to minus 5 on both sides. And then I will get negative 4x is equal to negative 4. Divide both sides by negative 4 to get x is equal to 1. I now plug that value right back into here to get y equals negative 2 times 1 plus 5, to get y equals negative 2 plus 5, to get y equals 3. So your ordered pair is 1, 3. please go ahead and stop the video here and watch the next one.